think this is going to be the last of the application of integration area between curves problems. Just wanted to look at this one. And this one, the way we're going to do this one a little bit differently is we're going to pretend for a second that we don't have a calculator, and we're going to pretend for a second that we don't know how to graph these functions, that they're too complicated to graph, and there may be something to that. First, we start with this. We want to find the area between f of x equals negative x squared plus 4x plus 1 and g of x equals x plus 1. So here we have a minimum parabola here and a line, and there's some area between them. The area, this is really crucial, that the area here is, the definite integral of f of x minus g of x dx from a to b. What's really important, a couple things about this, is that we have these two functions, and I don't know which one is which yet. Have one function that maybe does this and another one that possibly does, I don't know, that. And without regard to what we find that they're named, when we're trying to figure out which is this and which is the other, the one that's on the interval that we're interested in, the one that's on top, is f of x, necessarily. And the one that's underneath here is g of x, because we're looking for the area between the two. So how would you find the area between the two? You take the area of the top one minus the area of the bottom one, and that's how you find the total area. So that's really important. And it says from the interval from a to b, and a to b is, this a to b is those points, the interval between which they intersect. So they intersect here and they intersect there. So what we're going to have to figure out first is, where do these intersect? So we start with that question: where do our functions intersect? Where do they intersect is the question that we have to answer here. Where do they intersect? So what we're going to do is it's really pretty simple. It really is just algebra 1. We're just going to set them equal to one another, is equal to x plus 1. Now what I am going to do here is just to keep this negative coefficient, I'm going to move everything that way. It doesn't matter. It can be done either way, but it's the way I like to do it. So it's going to end up looking like this, isn't it? Going to equal, the opposite of this is x squared. The opposite of 4x is negative 4x and minus 1, right? It was a plus x here and a positive 1 there. So all I did was just move the opposite of this over, just added this to both sides to get rid of it. And we said equal to 0. I'm going to simplify this a little bit, and it goes to x squared minus 3x, doesn't it? Right? Minus 3x, negative 4x plus x. And these two cancel, so equals 0. I'm going to factor this out a little bit. So right now, what I'm doing right here is I'm trying to find these, I'm looking for the x values where these things intersect. So I'm going to factor this out. Here's 0 is equal to, I'm going to factor out an x, so x times x minus 3. So when does that equal 0? Well, when x equals 0, or when x equals 3. So, okay, they're going to intersect twice. That's what we know so far. And now I guess the next question comes to, so we have, what do we have now? We have this, right? We're gathering up this, aren't we? So we're trying to figure out what's the interval. Well, they intersect at x is 0 and x is 3. So this 0 is that one, and this 3 is that 3. So there's some good news. Now the question is, which function is on top of the other one on that interval? Which is over the other. And it's really simple to figure out. All you have to do is take a number on your interval. Take some number between, in this case, between 0 and 3, and plug it into both. So take f of, I'm going to choose 1 because 1 is between 0 and 3. F of 1. Now I'm going to take g of 1. And f of 1 is 4, I believe. And g of 1 is equal to 2, right? Is equal to 2. And therefore I know this. On the interval that we're interested in, so f of x is greater than g of x when x is greater than 0 but less than 3. So right, so that tells us this. So now what I believe is that we have this. I said I wasn't going to graph this, but I believe we have something like this. Without regard to where we are on the Cartesian plane, we have this thing right here, and we're looking for this area in here. And that on our interval that that the parabola is higher. So that gives me something to work with, I think, because now I can start to set that interval up. And I can say, okay, I'm interested in the interval 0 to 3, and I want the area between the curves. So the first curve was, and I had to figure out what the top curve was. This is the f of x curve, right? The top curve is x squared plus 4x plus 1 minus the curve that we think is lower, and we think that the line was the one that was lower, and that was, so minus x plus 1 dx. All right? So I think we have this set up, and this is a little bit tougher for me because I'm a little bit visual, and I kind of wanted to see this. We know what's going to happen here. We've done this before. This is exactly what this looked like before, and what we're going to get is this. We're going to get the definite integral, and then we're going to look. This is going to be negative x, so here's the negative x squared, and here's positive. This is going to be a negative x here, so it's plus 3x, isn't it? And then this is going to be a negative 1. Here's a positive 1. They cancel out, don't they? So we have this dx. Okay, so I think that gives us something, and of course now from here it really gets very straightforward because now we're just going to go ahead and integrate. So we're going to integrate this. Integrate, and the integration of this looks like this. It looks like equals negative x cubed over 3, doesn't it? Plus, right, this was x to the first, so it becomes x to the second. So it's 3x squared over 2. Isn't that right? Is that good math? Sure it is. All right, as evaluated from 0 to 3. So we have all of that done, and all we're going to do now is just we're going to start to, if you don't mind, we're going to start to use the fundamental theorem of calculus here. We're going to say the fundamental theorem of calculus that suggests to us that f of b minus f of a gives us the area that we're looking for, doesn't it? And b is 3, so f of 3 minus f of 0 minus f of 0 equals, and then we're going to start plugging in these numbers. And I went ahead and did all the math here. After everything was done, got 27/6, which simplified to 9 halves, right? 3 goes into this 9 times, 3 goes into this 2 times, and that's the area. Now the good news for us today is that we can check this with our calculator. So let's go ahead and check this with our calculator really quickly and see where it takes us. So just went straight to our calculator. You're in your you got TI-89, or if you have a CAS, a TI Inspire CAS, either one of these calculators is really, really good for this. And you're going to go to your home screen. It's the button that looks like a house, home screen, and you're going to have choices, the same choices I do, and you're going to choose calculator. From there, you're going to go to your menu button. It says menu right on it, and that would be this button. It doesn't show up as well. It's right here, isn't it? Go to your menu button, and one of your choices will be calculus. And from calculus, please choose the integral. And we know what it is. We want it to be from 0 to 3, don't we? And we set this up, and we set it up as negative x squared plus 3x plus 3x. And if you set it up the other way, you're just smarter than me. If you had set it up 3x minus x squared, so you could hide this negative sign here, that would have been a good thing to do, but it doesn't really matter. And lo and behold, 9 halves. 9 halves. So I think this is our last one for this. I hope you're taking great notes on this. You're going to see this, so good work. Vaya con Dios.